Mr. White.
Mr. Johnson.
And welcome to Chapter 3.
Wow, we're almost there.
2/3 of the way there. And Chapter 3 is all about car safety. So Chapter 1 was about driving and how the law of the road related to the physics and driving. And Chapter 2 was all about sports and talking about work and energy and Newton's laws. So today we start our discussion on car safety. And so it does relate to Chapter 1. We're going to be learning different ideas from Chapter 1, but we're going to emphasize what happens if you don't slow down. Okay? So we took this little quiz today in class, and we tried to identify some devices in cars that make us safer as passengers. So, Mr. Johnson, from today's investigation and from what you know about physics, well, what do you think? What are some safety devices that relate to science and engineering?
Well, the one that really stands out when we're talking about cars is seatbelts.
Ooh, seatbelts.
I mean, that has a lot of physics in it.
Yeah. And we're actually going to investigate the seatbelt one day in class. And that has to do with one of Newton's laws. And I'm going to leave that a mystery. Little cliffhanger there.
There you go.
Yeah,
Keep them interested.
Stay tuned. What other safety devices that are common in cars, what do you think they have to do with physics?
Oh, well, nowadays with all modern cars, something that's kind of similar to applying the seatbelt is the airbag.
Airbags. So now, when a car is made, by law, cars now have to have airbags.
Yes.
They have to have front airbags, passenger airbags. I don't know if side airbags are yet required by law.
I don't know if they're required, but I think a lot of cars have them.
Yeah,
They're just
side
trying
airbags.
to get ahead of the curve there.
They have these curtain airbags that actually come from the ceiling and move in front of the window so that it kind of creates a bubble for you to move around in.
So if you get T-boned,
Yeah.
you don't have put your head through the side window.
Right. And so when Mr. Johnson says T-boned, that'd be a side impact collision. So for those of you that don't know, it's like you're driving through an intersection and someone's run a red light and they run into the side of your car. It's a very dangerous type of collision that a frontal airbag isn't going to protect you from, and frankly, a seatbelt wouldn't protect you from either. The other one that I find interesting that, so we talked about seatbelts and airbags required by law, would be the head restraint. This is the only other one, I believe, that is required by law. And the head restraint protects you from a very particular kind of injury. Do you know what that kind of injury is?
I think it goes towards the whiplash effect.
Yeah, the whiplash injury. And this is also one of Newton's laws that we will be discussing this with. And once again, cliffhanger. Which one? Stay tuned to find out. But there's all kinds of other safety devices in cars to keep you safe. The other one we're going to study is called a crumple zone. And a crumple zone is designed to protect the front and the rear, to protect the passengers, and the front and the rear part of the car smash together. And as a result, the passengers in the cabin stay relatively safe. And this uses this new idea we're going to learn about called impulse and momentum. Now, I didn't talk about these two blanks up here, but these are ideas that you already know about. And I just glossed right over the top of them. But impulse and momentum, these are new to us, and we're going to talk about crumple zones at the very end of the chapter with respect to car vehicle safety. Cars have all kinds of features now that keep us safe. Some are newer than others. Anti-lock brakes aren't so new, but they keep us safe. The backing up detection systems are relatively new.
Those are nice.
Your car will beep at you if you're about to hit something behind you. Some of them have cameras, electronic stability control. Your car's onboard computer will actually, it can predict if you're going to be in a wreck. And there's this car commercial that talks about all this. It actually turns the car off.
Mm-hmm.
It prevents gas from flowing into the engine anymore. It turns your hazards on. The car can predict, based on your driving behavior, if you're about to be in an accident, if you can imagine such a thing. My favorite is the Corvette. Now, who doesn't love a Corvette? But I actually went to a physics talk on Corvettes, if you can imagine such a thing. And the guy that was there talking, he was the head engineer. And he knew everything there was to know about Corvettes. Anti-lock brakes, for example, were invented by Corvette, because they had this car that could go really fast but couldn't stop.
No.
And so they invented the anti-lock brakes to prevent you from crashing your really expensive sports car.
I remember there was a time when I learned how to drive. Anti-lock brakes were just starting to come out, where you actually had to learn how to drive when you slide. Turn into the slide, not away from the slide.
So this is my Corvette.
Whoa, that looks like a station wagon.
No, that's a Corvette, Mr. Johnson.
You need a little Woody on the side there.
No. This is a Corvette. Just here, let me look. Now it's labeled, so it must be true. So Corvettes have this electronic stability control thing that I was talking about. They, the wheels, obviously, when you're driving forward, go in one direction so that you go forward. So there's this feature you can turn on or off in the Corvette. It's on by default. You'd have to actually turn this off. Just press the button in your car. And the Corvette makes you drive like James Bond, where you can go into a turn at 35, 40 miles an hour. Now, in any other car, on any other day, that would be an awful idea, because you're not going to make the turn. You're going to slide.
Yeah.
You're going to hit something on the side of the road or somebody. Bad news. The Corvette can detect your stupidity, and it can actually reverse the back wheels of your car so that instead of fishtailing or power sliding or doing something you shouldn't do, you just come out of the turn, straighten out, and go. And once the car detects that it's going in a straight line, it allows the wheels to move as it should. You don't have to touch the brake. You don't have to do anything. The Corvette just does this for you.
So a car actually designed for 90% of its drivers.
Yeah. Now, don't get me wrong. You can still wreck this thing.
Oh.
If you're profoundly dumb, you can still smash this thing up pretty good. But it takes into account you're driving a Corvette. You want to drive fast around the corner. So this is what we need to do for our drivers of this Corvette.
Because everyone's a NASCAR driver.
Absolutely.
The corners.
Especially if you own a Corvette.
Right.
The brake system on the new Corvette, any guess as to the price?
Probably more than my car.
Yeah. Well, the brakes on this car would cost more than what I paid for my home almost 10 years ago.
Wow.
The brakes on this car cost $120,000.
Jeez.
Now, they last for 100,000 miles. That's the good news. They're made out of the same ceramic material that they put on the space shuttle to send to space.
Ooh.
But 120 grand for brakes on your car.
That's
intense. But if you're going to drive fast, you got to be able to slow down.
Yeah, you need something that's going to retain a lot of heat.
Yeah. So we talk about all these safety systems. And so all these ideas that we've learned about in Chapter 1. So let's see. Chapter 1 was speed, distance, acceleration, time, centripetal force. All those ideas are going to apply to car safety. Chapter 2. We talked about the first law, the second law,
Third law.
the third law, all, of course, by Newton. We talked about friction,
Yeah.
work, energy. All of these ideas.
Well, let's not forget the law of conservation of energy.
Ooh, yeah, conservation of energy. Good call. all these ideas are going to show up again in Chapter 3. So they're not going to go away. And we're going to add 2 more things. We're going to add, we already mentioned it, impulse and momentum.
Now, some of them, my students actually alluded to momentum a little bit when we were talking about Carl Lewis, who a lot of them didn't know who he was.
Yeah,
I was very disappointed. One of the greatest United States track and field stars ever.
Olympians, yeah.
But where he leaves the ground, where they were saying his momentum is carrying him forward.
Right, momentum is one of the first terms that we're going to talk about that we're familiar with. Okay, so we're getting off of election season, and all of election season, who had the momentum in the month of October? Who had the momentum going into election Tuesday and so on? So that's a term we heard. I hear sportscasters talk about momentum coming out of the locker room at halftime, or who has the most momentum in the final 3 weeks of the season.
Or a shift of momentum in a game.
Right. And so you hear sports broadcasters talk about this all the time too. So a lot of these scientific ideas, they do show up in our everyday culture. And we just need to maybe adjust your view on this a little bit and bring it to science class. I believe that wraps things up. So we're getting you started on car safety. So in Chapter 1 we said slow down. In Chapter 3 we're saying if you don't slow down, this is what's going to happen.
Well, not only that, if you take anything from this podcast, at least you can show it to your parents and say, hey, Corvettes are safe.
And there's one more thing. Yeah, Corvettes are safe.
They're designed for idiots like me.
I got to tell my wife that. There's one more thing I wanted to say. This is going to be a recurring theme throughout all of the chapter. I wanted to get this covered. And it sounds crazy. Longer crashes equal safer crashes. And we're going to leave you with that. And it's going to be our goal to prove that this chapter. So signing off, this is Mr. White.
And Mr. Johnson.